Okay, this is part C. The system is linear or not. First, I assume input xt is x1t. Then I check what is output for that. The output yt, for this input signal I show that by y1t, and this equals the integration over h of theta times the input, and input is x1, and there is a time shift here, and then d tau. Alright, that would be the output. I do the same for the second input. The second input is x2t, so that means yt becomes a different output, and that output equals the integration of product of these two functions, these two signals, ht times input is x2t, but shifted by tau, d tau. Alright, so now I give a combination of the first and the second input to the system. So that means the input to the system becomes alpha x1t plus beta x2t, and for this the output becomes, okay, let's calculate the output, but again, okay, what we expect if the system is linear, the output yt should be something like alpha y1t plus beta y2t. Okay, and if I expand that, then yt should be alpha times, this is y1t, alpha times integration of ht x1t minus tau d tau plus beta, this is y2, h tau x2t minus tau d tau. That's what we expect to see at the output if the system is linear. And I'm gonna check the output for this input. So this is the input, alpha x1t plus beta x2t. I'm gonna find the output based on this expression, and then check that with what we expect from a linear system. So yt is integration of h tau times input. Input is alpha x1t plus beta x2t. Sorry, I made a mistake here because there's a time shift. So this is a minus tau plus beta x2t minus tau d tau. Okay, so I need to expand this expression here. I need to expand this and then check that with this. Okay, to expand this, we have two product here. One is here, one is here. So I multiply this guy here, h tau, to the first item and to the second item, and do the same for this d tau. I multiply that to the first and to the second item here to expand the whole expression. So I can write it here, yt is integration of minus infinity to infinity of h tau alpha x1 of t minus tau d tau plus h tau times beta x2 of t minus tau theta. Okay, so I can write this, I think you agree that I can write this like, so let's save time, and instead of again writing the expression again, I can write this like this. Okay, well, what I have done is we have integration of two items. Okay, I can do that like this. So this is, we would say, associative. So that's what I did. And if I compare now, one more thing is that this alpha is a constant. So for a constant, let's say for a constant like c times to a function, the integration of this, okay, we can take this out and write it like c integration of f tau theta. And I can do the same here. I can do the same here and write this like yt equals, I can take out this alpha and write alpha minus infinity to infinity of h tau x1 of t minus tau theta plus beta times integration of h tau x2 of t minus tau theta. And that's easy. If you compare this guy here, well, what is this? This is y1. Okay, if I compare that with this one, you see these two exactly match, and that's the same for this one. This expression here exactly matches with this one, and that means we can conclude this system is linear because superposition principle applies to the relationship between input and output.